Welcome to 5 Minutes VHDL podcast, the podcast we will talk about VHDL and hardware design. In the episode 5, we did talk about sequential logic. In this case, we introduced a fundamental concept on hardware design, the flip-flop. What is a flip-flop? Flip-flop is a set of hardware logic that store information about a state. It can store 1 bit or more than 1 bit. Let's see an example. In the picture on the Telegram channel, I put a representation of flip-flop and the truth table of a flip-flop. The basic flip-flop is the flip-flop of type D. D means data, basically. In the flip-flop, we can have a reset input, asynchronous reset input, asynchronous set input, optional, the input port D, and the output port Q. The other output port Q bar is not Q. Generally, we have D and Q as a basic input and output port. A fundamental signal on flip-flop and sequential logic is the clock. How flip-flop works? On every edge of clock, the input on D port is transferred to the output port Q. In the truth table, we can see that set and reset signal are asynchronous, means that these signals do not depend on clock. In fact, when set is 0 and reset is equal to 1, the output port Q is 1 and not Q is 0. When set is 1 and reset is 0, the output is 0. When set is 0 and reset is 0, the output port Q and Q bar are both 1. On the bottom of the table, when set and reset are 1, in this case the output Q depends on D, but the output Q takes the value of D only when there is a rising edge of clock. In this case, because this flip-flop is controlled on a rising edge of clock. So in this case, we have when the input is 1, the output is 1 on the rising edge of clock. If no rising edge of clock occurs, the output Q remains unchanged. This is the basic functionality of flip-flop. In the second picture, we can see how to write a flip-flop with a simple VHDL process. In this case, we have our architecture. In this case, the architecture of the flip-flop is very simple. We have an input clock, and reset, asynchronous reset active low means that when the reset is equal to 0, the output is 0. And not depend on the input and the clock. Then we have the input port D and the output port Q. In the VHDL code, we have the declarative part of the architecture empty and the simple process where the sensitivity list in the next episode we will address the process in VHDL. By now we are introducing some terms. So the process with a sensitivity list. In the sensitivity list, we have reset and clock. Then a simple process that implements a D flip-flop. So the asynchronous reset is if reset equal to 0, then Q less than 0. So output Q is under reset, no matter what clock and D do. In this case, the output is 0, but you can set the output to 1. It doesn't care. Else if rising edge clock, then Q less than equal D. That means on every rising edge of clock, the output Q takes the value of D. This simple VHDL code implements a D flip-flop, and the synthesizer understand this syntax and implement a flip-flop of type D. You can download the code from the Telegram channel and you can use it as template for your VHDL code. So, for now it's enough. See you on the next episode and ciao.